And so let's do the next problem. So the next example says the summation of r squared plus 1 as r leads from 1 to 4. So it means that we must be able to replace this r with these values, meaning from 1 down to 4 when r is 1, 2, we use 3, and we use 4. So the first one when r is 1, you have 1 squared plus 1, right? Plus, when r is 2, you have 2 squared plus 1. Plus, when r is 3, you have 3 squared plus 1. When r is 4, you have plus 4 squared plus 1. So we're going to sum all of these up. So this now gives us 1 plus 1. This is 4. 2 times 2 is 4 plus 1. This is 3 times 3 is 9 plus 1. 4 times 4 is 16 plus 1. So we have 2, we have 5, we have 10, and we have 17. So this is 7. 7 plus 10 is 17. 17 plus 17 now 10, 20, 30, 34. So 17 plus 17 is 34. So the summation of r squared plus 1 as r leads from 1 to 4 is equals to 34. Now, so let's do question 5 and question 6 quickly. Now, question 5 says the summation of k plus 1 divided by k minus 1 as k leads from minus 1 to positive 2. So it means that we must replace, remember, from minus 1 now, you go to what? 0. From 0, you go to positive 1. From positive 1, you go to positive 2, and so forth, right? Because remember we told you, this is n. n is the smallest, and this is n. n is the biggest. So the fact that n is the biggest, it means it must be increasing. So that's why we're going to replace k now with the value of minus 1. So the first one will be minus 1 plus 1 divided by minus 1 minus 1 plus, now let's bring this thing down because it cannot fit up there. So you have minus 1 now plus 1 all over minus 1 minus 1 plus the next sum you have from minus 1 now you go to 0. 0 plus 1 all over 0 minus 1. You move to 1. You have plus 1 plus 1 all over 1 minus 1. The next one you go to 2 plus 2 plus 1 all over 2 minus 1. So this minus 1 plus 1 is 0. 0 over 2 minus 2 plus this is now 1 over minus 1 plus this is 0 over, now this is 2 now over 0 plus this is now 3 over 1. Now because you have 2 over 0, this thing becomes undefined. So this kind of division cannot work. So even if you were to add this and this, you will still be adding it to this, and this division cannot work, so it is undefined. So let's look at this one. So we replace this r now with 0. So the first one is 0 plus 3 from 0 go to 1 plus 3 from 0 go to 2 plus 3 from 0 go to what? 3. So now any expression raised to the power 0 is just equals to 1 plus 3 to the first power is just 3. 3 times 3 is 9. 3 times 3 times 3 is 27. So this is 9, 10. 10 plus 3. 10 plus 3 is 13. 13 plus 7 is 20. 20 plus 20 is 40. So this is now 40. You want to do it backward, you can do that. 27 plus this 3 is 30. 30 plus 1 is 31. 31 plus 9 is 40. So that's how we find the sum of 3 raised to the power r as r leaves from 0 to 3. So we look at question 7 and question 8. So question 7 says the summation of r minus 1 divided by r squared plus 3 when I list now from 1 to 3, so it's 1, it's 2, it's 3. So we're going to use these three expressions, these three numbers now, to replace with R in our sum or our summa. This is summa, right? So now this is now equals, the first one, when R is 1, so we have 1 minus 1 all over 1 squared plus 3, right? Plus, the next one, when R is, now someone may ask, why is it I'm always writing plus? Because we are finding the sum of terms. So the next one is 2, when R is 2, so I'm going to replace this R now with 2, so it's 2 minus 1 divided by 2 squared plus 3. The next one, when R is 3, so I'm going to say plus 3 minus 1 all over 3 squared plus 3. So we do that now. 1 minus 1 is 0. 1 squared is 1. 1 plus 3 is 4. 0 divided by 4 is 0. So this one is just out. Plus 2 minus 1 is 1. This is now 2 times 2 is 4. 4 plus 3 is 7. Plus 3 minus 1 is 2. 3 times 3 is 9. 9 plus 3 now is 12. So therefore, this is 1 over 7 plus 2 over 12. So we find out our least common denominator for 7 and 12. That is to say, we multiply 7 by 12. So 7 times 2 is 14. 7 times 1 is 7 plus 1 is 8. So it's 84. So 7 now goes into 84. How many times? So 7 into 8 is 1 times remainder 1. You add this 4 to 8. 7 into 4 into 14 now is 2. So 7 into 84 goes there 2 times. So it's 2 times 1 is 2. Plus 12 now into 84. It goes there 7 times. So 7 times this 2 is 14. 2 plus 14 now is 16. 16 over 84. So we reduce it. 2 into itself into 16.
7 into 84 is that 2.
7 into what?
7 into 84 is that 2 times. I'm mistaken.
No. Okay, 7 into 84 is 12 times. Okay, so that's. So now we find our LCD again. Let's say we find our LCD for this expression. Now let's find our LCD for 7 and 12. So we have 7 and 12, meaning we multiply the two of them to easily find our LCD. So we notice that if we find our LCD, we will have 84. So 7 now into 84, it goes there 12 times, right? Now, how did we get that? You have 7, you have 12. So I told you to find the multiples first before those multiples now will then turn to the least common denominator. So the multiple now of 12, you have 12, you add 12 to 12 is 24. You add 12 to 24, now it gives you 36. You add 12 to 36, it gives you 48. You add 12 to 48, it gives you 50, 60, right? 60. You add 12 to 60, it gives you 72. And you add 12 now to 72, it gives you 84. Right? Now 7, there's 7. 7, you add 7 to 7 is 14. 7 to 14 now it is let's say 6 is 21. 7, you add 7 to 21 is 28. You add 7 to 28 now is 35. 7 to 35 is 42. 7 to 42 is 49. 7 to 49 is 56. You add 7 to 56, it gives you 63. You add 7 to 63, it gives you 70. You add 7 to 70, it gives you 77. And you add 7 to 77, it gives you 84. So if you look there, what is in the first expression and the second? Look carefully. What is here that is also here? Carefully look. So we found out that we have 84. 48 is here, 48 is not up there. So 84 is our common multiple, the least common multiple. So because we are dealing with denominators, we call it the least common denominator. So now 7 now into this 84, we check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 7 goes into 84, it goes there 12 times. 12 times 1 is just 12 plus. 12 now into 84. 12 into 84, we want to know how many numbers can we cross to reach to 84. 1, 2, 3, 4, 5, 6, 7. So it goes there 7 times. 7 times 2 now is 14. So therefore we add this 12 plus this 14, it gives us 26 all over 84. So we can further reduce it by 2. 2 into 26 is 1, is 3, 13. 2 into 84 is 4 and 2, 42. So it's 13 now over 42. So if we find the sum for this, it's just equals to 13 over 42. Now let's quickly look at the next one. So we find the sum of this. Now, in the next lecture, we're going to show you how to easily find the sum of this using sets of formulas without carrying on this long method that we are about to carry on. Because what if this upper bound was 100? If this upper bound was 100, for example, it will make it so difficult and so complicated for us now to say when k is 0, when k is 1, when k is 2, when k is 3, all the way to 100. It makes it so difficult. So, in the next lecture, I'm going to show you how you can easily find the sum of expressions of these forms. So now we have k squared plus 3k plus 2. When k is 0, you have 0 squared plus 3 times 0 plus 2. This is the first one, first sum. Plus, when k is 1, 1 squared plus 2 times 1 plus 2. Plus, when k is 2, 2 squared plus 3 times 2 plus 2. Plus, when k is 3, 3 squared plus 3 times 3 plus 2. And the last one, plus, we bring it down here, when k is 4, you have 4 squared plus 3 times 4 plus 2. So we simplify. So this whole thing is just 0. This is 2 now. Here is 1. 2 times 1 is 2 plus 2. So it's 1 plus 2 plus 2. So this is now 4 and 5. So in there is 5. Plus, this is 4. So it's 4 now plus 6 plus 2. This is 10 plus 2, 12. Plus, this is 9. This is also 9. This is 2. So 18, 20. So it's 20. This is 16. This is 12. This is 2. So we add everything. 10, 20, 28, 30. So it's 30. So we look at 30 plus 20 is 50. 50 plus 12 is 62. 62 plus 5 is 67. 67 plus 2 is 69. So the sum of k squared plus 3k plus 2 as k leaves from 0 to 4 is equal to 69.